Welcome back. Here we are again talking today about gases and the mole, just what you always wanted. So last video we talked and kind of reminded you what the mole was, what molar mass was, what Avogadro's number was. Today we're going to talk about kind of the specific application of this to gases. The thing with gas is that it's kind of difficult to find the mass of it. I mean, like, how do you take a gas and sit it on a balance? You can try to trap it in a balloon or something, but it's kind of a pain. So usually with gases, we don't look at their mass, we look instead at their volume. But the kicker here is there's two things that affect the volume of a gas: temperature and pressure. Now, most of you guys are very well aware that temperature affects the volume of a gas. If you've ever had a bike, you put your bike in the shed for the summer or for the winter, you come back at the end of the winter, your tires are flat. It's not because some mouse ate a hole in them. Your tires are flat because the temperature affected the volume of the gas. It actually made it kind of shrink down a little bit. If you left them in there over the summer, they blow right back up again. Okay, you've heard hot air expands, things like that. So we've got to be very careful when we're looking at the volume of gases because they have to be at the same temperature and pressure in order for it to be a valid comparison. So what we call that is we call it standard temperature and pressure. Okay, standard temperature and pressure, and it's abbreviated STP. So when we talk about STP, let me flip over here to a new slide, it all goes back to Avogadro again. Avogadro actually said that equal volumes of a gas would actually have equal numbers of particles. Okay, that was literally an Avogadro thing, but only at a standardized temperature and pressure, which is what STP stands for. So standard temperature and pressure is 0 degrees Celsius and 1 atm. That's normal atmospheric pressure. So you're going to see STP and a lot of questions. And the beautiful thing about it is if you see STP, all it means is you don't have to worry about temperature and pressure. So if a question says, at STP, you have a gas, you just go, okay, good, I don't care about temperature and pressure. It's just a matter of them taking out all of the possible variables for you. But that's the deal with STP. So another cool thing about STP, back to Avogadro again, he said at that standard temperature and pressure, 0 degrees Celsius, 1 atm, equal volumes of gas have equal particles. So the equal volume was 22.4 liters. 1 mole of any gas will occupy 22.4 liters. It's called the molar volume, and it's actually a conversion we're going to use a lot. In fact, we're going to add the molar volume to that big string we had last video. So last video we said 1 mole is the periodic table grams, which is equal to Avogadro's number, 6.022 times 10 to the 23rd, worst time sign ever. Okay, and that's pieces, particles, atoms, whatever. Well, now we're going to add, that's equal to 22.4 liters at STP. So nifty thing here is all these gases have the same volume, but they can still have different masses. So what do we do with this? I told you it's all about math this chapter. We do conversions. So questions you may have is, what is the volume of 4.59 moles of carbon dioxide at STP? So if you're talking about volume, you're talking about liters. That is a nice, simple conversion. 4.95 moles, 59 moles. Moles down there, liters up here. And like we said before, 1 mole is 22.4 liters. And there's a couple more practice problems in the PowerPoint, definitely worth taking a peek at. Another kind of version you may see is I have 8.8 grams of CH4. What's the volume of that? And you set it up the same way. That's the really cool thing about all these conversions is if you just get in the pattern, you can do any one. Give it on the top left, unit on the bottom right, looking for liters. Now I got to think liters and grams. Liters and grams. Well, let's go back and look. 1 mole equals, periodic table grams, equals Avogadro's number of particles, equals 22.4 liters. So 22.4 liters, grams off the periodic table, carbon's 12, hydrogen is 1, add it all up, I get 16. So molar volume, first use, Basic, simple conversions. The other thing we're going to do with molar volume is we're going to use it to calculate the density of a gas. Okay, so you guys know density is mass over volume. Not too difficult. For a solid, it was grams per cubic centimeter. For a gas, it's grams per liter. But basically, to find the density, we need to know the mass and we need to know the volume. I mean, hello. So the way the questions are written, though, it says find the density of CO2 at STP. Now, I'm with y'all. I'm all about the math. So here's the problem. Great. I know my formula. Density equals mass over volume. And I go to plug stuff in, and I look at the question, and I get one of these numbers happening. Like, because I don't see any numbers. And that's my issue. Like, there's no numbers in the question. Well, here's the coolest thing ever about chemistry. Let's just assume that you have 1 mole. Remember, density is one of those properties. It doesn't matter how much you have. It always stays the same. So if I just pick a mole, I know now that my volume is 22.4 liters because 1 mole of any gas is 22.4 liters. And if I assume I have a mole, I can find the mass by looking at the periodic table. So if I go to the periodic table, the mass is 44. That's in grams. And so I end up with 1.96 grams per liter. Sad but true, I know that one off the top of my head. So it's kind of a nifty little trick you can do. If your SOL is trying to be annoying, which we all know they sometimes do, they may ask you something like this. What is the molar mass of a gas? It rhymes. With a density of 2.86 grams per liter. Again, you know, you get all happy, you write down your formula, and you're like, ooh, density is 2.86, yeah. X is my molar mass, yeah. Oh crap, what do I do for liters? 22.4. So it's stuff you can kind of go back and forth with. Molar volume, density, pretty straightforward, pretty simple stuff. The longer stuff will be coming in the next video.